Hello students, a very warm welcome to Gravitation lecture number 14. Hi Shoham Roy, hi Organic Hodeska, hi everyone, and a very good evening to this. This is going to be a very interesting lecture. It's going to be really interesting, students. So stay tuned. And one more thing about today's lecture, it's going to be probably one of those probable topics that can come JEE Mains and JEE Advanced. So this I am predicting from your electrostatics. Basically, questions in your JEE Mains have started coming from this specific chapter, and it is often correlated. Many of your lecturers and faculty will correlate gravitation with electrostatics. That way, I'm expecting similar question can be asked in your JEE Mains or JEE Advanced, mostly JEE Mains. From the topic that we are going to do now onwards, and it can also be the initial questions can also be a JEE Advanced kind of questions. So what are we going to do today? We are going to deal with something known as how to derive electric field from electrostatic, gravitational field from gravitational potential, etc. Okay, so this is going to be the part of today's lecture, and you can apply the same thing in electric. So do pardon me. Yeah, it's very interlinked topic. So often you will come across people speaking about electric field while they are trying to speak about gravitational field. So yes, given a gravitational field, how do you derive gravitational potential? Given a gravitational potential, how will you derive a gravitational field? And we'll be discussing many such scenarios, because this can be one of the most probable topics in your JEE Mains and JEE Advanced. We'll have a lot of problems around this topic, so it's going to be super interesting. Stay tuned. And that being said, students, I'm Muralidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I have filed 25 patent applications in India, US and Canada, and that too on the state-of-the-art technology, and I have a track record of winning several national level science and tech competitions. And that being said, students, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's of course going to be Unacademy subscription. Why do I say that it's going to be Unacademy subscription? Because we have aggregated the best educators across the nation on a single platform. That's going to be an Unacademy subscription platform, and you will get to attend daily interactive classes with the best educators across the nation. Yes, of course, that is an amazing part about your Unacademy subscription. Not only that, you will be attending these classes on a very interactive and attractive platform with lots of polls and leaderboards. Of course, this is going to be one of the best things for your JEE preparation. So think about it. Your learning is becoming interesting and fun on Unacademy subscription platform. And that being said, Unacademy subscription comes with a lot of test series for your JEE preparation, which is one of the key parts of your JEE preparation. So let's say you are getting to attend test at a national level and getting an analysis based out of this. It could have been, or it could be, the best thing for your JEE preparation. So yes, that being said, Unacademy subscription programs or structured programs. It's fully structured programs. You don't have to worry about the planning, etc. Everything is taken care, and you will get to attend live doubt clearing classes with these best educators. Not only that, you will also get to attend quizzes and mega quizzes. So every Unacademy subscription program, be it micro courses, droppers batch, 2-year-long courses, etc., will come with doubt clearing classes. Lots of doubt clearing classes. In fact, every 4th class is going to be a doubt clearing class. So that being said, yes, how do you avail this amazing Unacademy subscription? All you need to do is click on the left-hand top corner extension bar. If you do not have an Unacademy learning app, do download it, or you can do the same thing from the web-based version as well. Click on the left-hand top corner extension bar, click on this plus icon, and then choose IIT JEE as your goal, and then hit on this get subscription button. And students, yes, other amazing thing about Unacademy subscription is it's only one subscription for unlimited access. So you can access both JEE Mains and JEE Advanced program on Unacademy subscription platform. So that is an amazing thing about Unacademy subscription. So yes, there is no batch restriction, etc. And what about the pricing? Coming to the pricing part, Unacademy subscription is quite reasonable. So if you look at Unacademy subscription prices, if you are in 9th to 11th class, we typically recommend that you go for a 24-month subscription. which is going to cost you only 50,400. And how much is this 50,400 turning out to be per day? It's like less than 70 rupees a day. You can do that math. You just divide 3,400 by 700 and odd, I think 365, so it's like 730. You will get out the answer. Okay, so that is less than 70 rupees a day. And coming to like if you're a long term or dropper, we typically recommend that you go for a 12-month subscription, and a 12-month subscription is also pretty reasonable. All it is going to cost you is 34,650. Yes students, all it is going to cost you is 34,650. That's less than 2,900 per month. And yes, we do also have something known as iconic subscription. Whatever we were discussing up until now was about plus subscription. On iconic subscription, you get everything as you get on plus subscription. Along with that, you will also get access to IITians and IITians who have previously cleared JEE Mains and JEE Advanced. This way they will be able to guide you throughout this entire journey with expert guidelines, strategy sessions, live workshops, etc. And they will be fine-tuning your preparation throughout this journey. So this is one of the best things for your JEE preparation. If you can afford it, yes, this is going to be definitely one of the best things. And coming to the pricing part, how much is this going to cost you? If you go for a 1-year subscription, it's going to cost you only 58,500. And if you go for a 2-year subscription, it's going to cost you less than 50,000 per year. That's like 45,000 a year and 90,000 for 2 years. And you get to this pricing. And of course, you'll get the best maximum discount by applying Murali Live code. So make sure you apply Murali Live code for best maximum discount, students. And this is not just on Plus, Iconic. Any features that you unlock on Unacademy, you can do it using Murali Live code. So make sure you're using Murali Live code, be it on 6 months, 12 months or 24 months Plus or Iconic subscription, so that you can avail the best discount. Do not miss out the discount. Not only that, students, you know what, you can unlock many more features using Murali Live code on Unacademy app as well. So try it out. So let's get into this lecture. Let's not wait anymore. We have like an amazing question coming up. Why do I say this amazing question? This is really one of the best questions. Actually, this makes our life easy. One of the things is this is really going to make our life easy. I'll come to the rest of the parts as well. So I don't know why does this happen all the time. It was supposed to be a gravitation. Okay. So we have the magnitude of gravitational field at a coaxial point P at a distance √3r from the center of the ring with mass m and radius r. And students in who are like 2022 aspirants, do remember one thing. If you understand this gravitation topic really clearly, you wouldn't have any issues in the future. What do I mean by you wouldn't have any issues in the future? You would not be facing a lot of mathematical based issues, or many a times even many model problems kind of thing are covered in gravitation. And this is the same thing you'll be studying in electrostatics to some extent, not all of it. Gravitation is somewhat a shorter chapter compared to your electrostatics. Electrostatics is a very lengthy chapter, whereas gravitation is comparatively shorter chapter, but many integration, everything would become easier. In fact, if you are willing to do this, you can apply some techniques that you are learning over here in electrostatics. So you know what, give your best focus during this preparation, and of course we are discussing everything in full length, so do not forget to share this. And this is a free of cost initiative in Unacademy, so definitely do share it with your friends on social media like WhatsApp, Facebook, Facebook groups, and like Google Plus, etc., Twitter, etc., wherever you can share it, Telegram channel, etc. Do share it, students, definitely do share it. And we'll get into it. Definitely do share it, because someone may get access to this free of cost lectures. So yes, that being said, what is being asked? The magnitude of gravitational field at a coaxial point P at a distance √3r from the center of the ring with mass m and radius r, where mass m uniformly is distributed throughout its circumference. Now, coming to this point, how do we work around this problem? See, one of the ways is you can go by gravitational field method. But what we are going to do today is going to make use of gravitational potential. That is how we are going to get started with this question, because this question can be really easy. So first of all, as I told you, what we are going, why is that really easy? It's actually both of the ways you can go. There is absolutely no restriction. No, actually, if you look at the symmetrical points, it's all cancelled out. But if you start with gravitational potential, right, you can make use of this even for, two-ring system, three-ring system, n-ring system, and solve it very easily compared to a gravitational field. So that is the reason we are moving with gravitational potential. Okay. So let's say, like, how do we calculate your gravitational potential at some point? We will be typically such questions will be taking a dm because like there is the distance of this dm, like this ring, is different than what we are expecting. We are not moving by center of mass concept. So carefully notice this thing. So let's say you have an angle theta, right? You can think about this having theta with the ring all the time because this distance is constant. You take at this point, imagine in three dimension a circular ring. Any elemental mass would be at the same distance. Any small elemental mass of mass dm would be at the same distance from that elemental mass to point P. It's always going to be R. Maybe in different axes, but it's always going to be R. The magnitude is going to be R, right? So what is the value of R that way? Okay, let's take a point like this. R is how much? This is radius R. R is going to be under root of R square plus of Z square, and which is the thing that is going to vary? Of course, Z. Okay, Z is the varying thing. Now, coming to gravitational potential, how we used to do it? We used to take an elemental mass, right? So even in this case, we'll be taking an elemental mass, that is dm. So let's start with the elemental mass and we'll be integrating this elemental mass. But I guess lots of explanations are not needed in this case. So dV potential is going to be how much? G into, for that elemental mass, it's G dm by R. Okay, there would be minus enough. So if you integrate it, you will get the total potential, net potential due to the ring, going to be integration dV, that is going to be integration of minus G dm by R, right? That is going to be minus G by R integrated dm. But let me ask you a question. When R is constant, what is the thing that is varying? Nothing. It's as if that bunch of particles of mass m are arranged in a circular pattern at a distance r away from the point, and you are basically adding. It's really that simple. Okay, if someone asks you for potential of ring, basically going to be minus gm, capital M, because integration of this mass dm is going to give you mass of the ring. That's it. There is nothing deep enough that you need to think about. You are correct. All these elemental masses are at constant distance. You're not. That's why we are starting from the gravitational potential. So what is the value of R? R's value is under root R square plus Z square. Okay. Now there is a very interesting thing. If you have noticed it, of course going to be negative. Those all things are all fine. Now the question arises, like, how do we derive electric field? And one more important thing, what is the potential of the ring at the center? If this is your ring thing, you can remember this. I would recommend you remember just this part, how we got to this logic. If at all the mass is changing, still it does not matter. Like even if it has like non-uniform mass density, still it does not matter. Literally does not matter. It's pretty easy, right? It's really quite easy. So coming to this part, can you think about one thing? What is the potential at the center? So we are going to get into the gravitational field question, and coming to this part, at the center, what do you think is going to be your Potential. Substitute Z is equal to 0. At center, what is the thing? At center, Z is equal to 0. If you substitute Z is equal to 0, what are you going to get as V ring? It's basically minus Gm by R. This is another such example where the field is 0, but gravitational potential is not 0. Yes? One was that sphere thing. We are moving inside the sphere of an hollow sphere. There was a constant gravitational potential, hence we said that there is no field. And then we discussed about one more case. We had a hollow sphere, we had a solid sphere, and then we assessed and we found out gravitational potential like a constant value and your field to be 0. And this another such not constant value but some value. And similarly, even in this case, gravitational potential is non-zero, whereas gravitational field is 0. Alright, but we are supposed to derive gravitational field at any point Z. Of course, that's not going to be 0. Before we proceed into the calculation, let me give you a small understanding of this. You take two symmetrical elements. If you take two symmetrical elements, assume this to be like, to be some x-axis. If this is z-axis, this to be an x-axis. And if you try and calculate, gravitational potential due to both, one component will get cancelled out. Net gravitational field, I mean like the field is going to be in this direction. Okay, theta and theta would add up and they would all be in this direction. That's it. It's a very simple question. So if my mistake, wouldn't be in that direction, right? Would be in the opposite direction. Right? Field is going to be in this direction. So you can understand it this way. One component and one component, if you add up, those two components will have net resultant in this. Okay. Now, this being said, how do you assess the value of this field and how do we do this deviation, etc.? Magnitude is basically being asked. Everything is in the minus z cap direction. Any such elements you can. Okay, let's do a thing. Let's take this element and this element. This element direction is going to be this. Take this element, direction is going to be this. Net would be in this direction along z. Okay, minus z cap. Okay. Now we are supposed to only derive the magnitude and finally talk about the. And anyway, direction is not being asked. And coming to this point, how do we derive this? There is a very simple way of doing this. If you remember, gravitational field magnitude is going to be minus dv g by dr. Okay, but in this case we can say this as dvg by dz because z is the only varying thing. Radius of the ring is going to be the same. Okay, that's it. There you go. You got the answer. And to derive the field, you need to like differentiate which equation? You need to differentiate this equation. That equation is going to be minus d by dz. In the brackets, you would be having minus gm by under root of r square plus of. Coming to this point, if you're wondering the final result is going to be negative, then should I be using minus z cap or plus z cap? You should be just adding a z cap because we are already giving it a negative sign from the beginning. Since the beginning, the only reason is it's an attractive. You just do correct that point. I often describe it in the reverse way. I'm so used to, like your what. Now let's come to this point. Okay, let me do a thing. Not write it down like this. Okay, students who know it, very good, great, very nice. Okay, minus minus, this is going to be GM. Now what am I saying is, let's turn this into something. Just for the ease of calculation, we'll be calling this as r square plus z square to the power minus 1 by 2. Okay, so I'm supposed to differentiate this term. What would you get once you differentiate this? Differentiate it. Let's differentiate it on the next page. Okay, I'm going to differentiate this term. 1 is to the power minus 1 by 2 will be there. You need to then differentiate this term, which is going to be minus 1 to a thing. So this would be, just notice it, we'll write it down again. When differentiated with respect to z, r is constant, r square would be there. R square plus z square to the power minus 1 by 2, that would become r square plus z square minus 1 by 2 minus 1 on the power, so that's going to be minus 3 by 2. And this would be multiplied with minus 1 by 2, right? And then what do we have? We have z square that we are supposed to differentiate, that's going to be 2z. That's it. Differentiate the old term. If you are not very comfortable with this, you know what you should be doing. One of the things I think that would be, that is something that you know from your math. You can take r square plus z square as some like x square etc, or r square, where that r square is varying. You should be deriving the value of dr. So that is one of the ways of moving about this problem. Alright, but yes, that way we did it. Okay, I believe everyone got this thing. Let's try it out once. So we would be having z on the top, and it would be all minus, okay, this is not yet magnitude, this with a sign actually. So minus gm, and then on the top, if you remember, we add a z, then this would be like an r cube actually. R square plus square to the power 3 by 2. And you'd be adding just a z cap. That was just for you to understand the direction. And you add the minus, it will be okay. Minus is already present, just add the z cap, do it. Okay, that's it. Now this is your final result, and how do we proceed about this? That's it. That's the answer. There's nothing you need to think. Just substitute the value of c. Get the answer. We were supposed to find it out at root 3r, isn't it? So it's basically root 3r distance. So you need to find it out at root 3r distance. So that being said, e.g., okay, your z is, in this case, root 3r. That's substitute the value. Okay, that is where the magnitude of field was being asked. When I'm going to talk about magnitude of field, I'm not going to consider the negative sign. I'm going to omit the negative sign. That's basically gm. So z is root of 3 into r divided by under root of 3 whole square plus of r square to the power 3 by 2. That's it. So you work around them, and you'll be getting like 3r square plus r square. That's going to be 4r square. So you'll be getting the 4r square whole to the power 3 by 2. You take a root. Hi, green, blue. Hi. That's it. I believe this is easy, pretty easy. Okay, you'll have a root 3 GMR. Now coming to the point, what is this? This can be like written as, under root. This is just basically 2r whole square. Okay, so what am I going to do is turning it, instead of writing it down as 4r square, I'm going to write down something like this. Then I can cancel out this and this, and then we have a cube. So coming to the magnitude part, what we need to do, just need to Eg magnitude, that is the gravitational field magnitude. It's so simple, right? Even the other way also it's simple, but many times you may want to use this method sometimes to calculate non-uniform mass distribution, whether this would be applicable. That's something that we need to rethink. That would be like 8r cube. You'd be having 8r square. So the final result is going to be something like root 3 gm divided by 8r square. Hi, nothing piece. Yeah, depends on your paper. Nowadays, it is totally going to depend on your paper. Given the more number of paper students, your preparation, at least as far as some subjects are concerned, they should be perfect. Yeah, I've been saying this since the beginning. So yeah, you can expect 2 questions sometimes. It totally depends on the paper, etc. But a very easy topic according to me. Okay, very easy and very simple and etc. Okay, so that way I think it's worth pursuing this topic, because it will hardly take like an hour a day, less than an hour a day sometimes, and you can complete the topic. That is the amount of effort that you need to put in. That's it, students. It's a very simple question. It was a very simple question, wasn't it? No too much thinking, etc. Just what did we do? We found out the gravitational potential, and then we made use of this relation. This is the key relation, and then we derived. Okay, that's it. Try it out once yourself as well. But we have a very interesting question. How many questions should we do per day? So yeah, coming to this point, students, how many questions will you be doing per day? As many as possible. 50, 60 combined physics, chemistry, math. Definitely 50, 60 combine your physics, chemistry and math, not less than that according to me. I would say, 50, like 20 questions from your physics. Why not 20 questions? Yeah, 30 questions is okay. 30 questions, you mean just from physics? Yes? Yeah, 30 questions just from your physics is fine. Absolutely fine. Yep. That is amazing actually. 30 questions, but try to complete each topic. If you're learning about gravitation, right? See, most of the problems you're discussing in the class, if you're attending the session, most of the problems you're discussing in the class. Your objective should be like to, score better in your examination in this topic, or if you have a dedicated, like quiz or something, you should be doing. Very good. 30 questions. Don't, more than 2 to 3 questions should not be of the same kind, unless I'm explicitly discussing it. If I'm explicitly discussing it, maybe, there are some confusions involved, those kind of things. Yes, very good. 30 questions, really amazing, nothing please. Really good. 30 questions is amazing, really good. But yeah, given that you are in first year, I mean like 11th class, droppers, this is not definitely for you. Droppers, you're not going to do 30 questions, you are going to max out. Max out could be like 50, 60, because at your potential, right, you would be able to solve problems in like a minute, like 30 seconds, depends, like, some questions in your books are going to take 30 seconds. So you're not going to say that I have solved 30 questions, that consumes 30 seconds and 15 minutes. It should be good questions, but try to maintain the completeness. Covering different questions. So students, here is the advice, be it you're in first year or second year. what you should be trying to do is you should be trying to try and maintain completeness. There's no other solution. Try to complete one topic perfectly and then think about jumping to another topic. If you are in second year, yes, that applies to you as well. If you're in second year, try to max out. Max out means 1/3 of the time, or if physics is your favorite portion, take 40% of your time and max out. That should be your objective. It cannot be like, you're doing physics good, but you're allotting 10% of the time. That does not work. So 30%, 30%, 30%, like 33, but you can do also like 40% sometimes physics. It works, it's a safe subject sometimes. But yeah, 40% of your time, let's say you are a dropper, or if you're in second year, that's a little different thing. You need to manage two things. That is going to be a board and but let's say if you're a dropper, you might be spending 8 hours a day on your preparation, like 1 hour, 2 hour theory. So you would be having 3 to 4 hours for problems. 30 questions is good. Max out, try to max out. That should be one of your objectives. 30 questions is really good, nothing. But from same topic, from same topic means if you're starting out at some point, try to cover the syllabus up until some point. That is more important. Okay, now let's get into this question. The value for Z from the center of the ring with mass m and radius r for which the gravitational field is maximum. Okay, for which the field is maximum. So in this case, what do you think is going to be the answer? How many marks to be score minimum? In which? I didn't get your question, nothing, please. In your JEE mains? JEE mains or JEE advanced? Sorry, JEE mains or during your test series? Or even in JEE advanced? What's your goal like? In your JEE mains, I'm assuming if you solve 80% of the paper, that's good enough. Totally depends, but 80% is good enough, right? 55 is not enough, nothing. Try, students, from day one set your target high. I'm not saying, I don't know, I haven't analyzed it. So if you remember, to get a 99 percentile, you used to say if you do 70% of the paper, you can get 99 percentile. Yeah, generally 70% of the paper correctly, you can get 99 percentile. But does not matter. Aim high. Like aim high, eventually it will happen. Trust me, eventually it will happen, right? So try and aim bigger. Your goals should be bigger, students. Your goals is what matters, right? Later comes, how much am I going to score in future? Put in your maximum efforts. Then look at your result. Not thinking how much I should be targeting. Move strategically. I'm never denying never move strategically. But max out. Maxing out is the most important thing. Even you are competing a national exam, one of the toughest exams for your engineering. Even you can consider this to be one of the toughest exams globally for your engineering. So that way, try to max out. Okay, works well and good. If does not, fine. Okay, don't think about how much am I going to score, is this enough, etc. You should be passionate about what you are doing. Later on comes what you're aiming. Okay, like good to think. I generally give you that statistics because you can move on your syllabus accordingly so that you have that data. It's not because you have the data so that you're only going to prepare 70%, etc. It should be like you're going to prepare 70% if time is only there for 70% of your preparation. So you should be preparing those topics like current and electricity, like maybe for JEE Mains rotational motion, maybe gravitation, maybe units, dimensions and measurements, definitely units, dimensions and measurements, maybe like electrostatics, maybe like magnetism, maybe like thermodynamics, KTG, these kind of topics, easy, optics, etc. Easy small topics, you pick them up. That is what I mean by move strategically. Finally, in your exam, you never know, your paper comes up from your paper can be like 70% from second year. So don't worry about it. Okay, so please remember, students, nothing is good enough, nothing is bad. Okay, whatever you're doing, do it with your fullest efforts. seek something wholeheartedly, it will happen. There's no one that can stop your success if you are doing it dedicatedly. Okay, all right, let's get into this question. So I think you must have got your answer. Yeah. So this is the field value that we derived, GMZ divided by r square plus z square to the power 3 by 2. You can remember this as like GMZ by r cube as well, where r is the distance from any point on this thing to this place. Now coming to this point, which is that capital R. So how do you derive a max of field? You're basically going to differentiate it and say it's going to be 0 at the point where I'm going to get 0. There, z should be the value. At that point, you're going to have maximum field. That's all you need to do, right? So this is your field value. We just derived it. You can derive it. 1 second. I just remember it. You can derive it, but you can even remember it using what I've told you. That's going to be minus GMZ by r cube. That was GM by R. This would be GMZ by R cube. And with direction, it's Z cap. Just add a Z cap. If not with negative, add with a negative. Okay. Just, you know what? Just a moment, guys. Okay. Yeah, let's get into this problem. So, yes, students, now let's get into the next problem. All right. So now let's okay, this problem we haven't solved, really sorry. Yeah. So now let's see. Now the thing is, if I differentiate this with respect to z, I'll be getting 0. That's what it should be. I'm going to differentiate this term. It's going to be minus, so two differentiations exist. I'll highlight. Okay, this is typically for students who are totally new to differentiation, but students, keep learning. Okay. Two things exist. It's basically multiplication of two z functions or two x functions, if you'd like to think about. Okay, so z is like x, you can consider it to be like an x. So there are two functions, one function in the denominator, other function in the numerator. So if I'm going to differentiate it, like let's say some f1z and you have f2z. And if I have to differentiate this with respect to z, what would you be doing, students? You should be like differentiating first function or second function, whichever you'd like, and multiply with the function that is not yet differentiated. And then there would be like, I think this is known as chain rule. I don't know, I don't remember, maybe like chain rule or something. So then you would be taking the first function and differentiating the second function. That's what we are going to do. Z is one of that function and the other function is 1 by r square plus z square under root 3 by 2. Sorry, to the power minus 3 by 2. It's as simple as that. Okay. So yeah. One thing you can do is, in such things, I can directly say this does not exist. The reason. This minus, gm, etc. you can forget. Because they're constant in both of the things, right? In both the calculations, in both this differentiation, if there is a constant, ultimately it's equal to 0. I'm not worried about it. So I'm not going to think about this minus gm, etc. Only z by z square plus. So basically what I'm saying is, since it's equal to 0, you're only worried about this term. That is z by, let me write it down this way. So it's pretty easy. If you are noticing it, z into r square plus z square to the power minus 3 by 2. Don't forget the minus 3 by 2 is equal to 0. Okay, now let's differentiate it. I think this is a very easy task. So first one is dz by dz. So that is 1. I'm differentiating the first function and I have r square plus z square to the power minus 3 by 2. And again there will be a z added plus of z into plus addition of z into r square plus z square to the power minus 3 by 2. When differentiated, what does it give you? 1 would be minus 3 by 2, right? And then you are going to take it as r square plus z square. So the power would come, and the power you should subtract it from 1. So that's going to be r square plus z square minus 3 by 2 minus 1. That's going to be minus 5 by 2. Now that being said, z square you have to differentiate. Right? Next thing should be z square. You are differentiating the same function just like how we did earlier. It's going to be 2z equal to 0. That's it. Now one more thing. As usual, we'll be taking that lazy route which makes everything easy. Okay, that's not actually a lazy route according to me. It's a very easy route, right? So just minus 3 by 2 is going to ultimately come down, and it's going to be cancelled out, and it's going to move on the the 0 side. So just take this to be minus 1. Okay, you'll be taking it on the other side and cancelling it out. I'm doing the same. Now it's a simple, we are doing like a math, this thing. So this is going to be 1 is equal to like a math session. It's going to be like that too, like a calculative math session. So this should be like, notice this. So 2 can get cancelled out. Then we do not worry about that 2 thing. All we know is it's 3z on the top, minus goes this side, on the right hand side it becomes 3z divided by r square plus z square. Okay, there should be a z square over here as well. Okay, z multiplied with z. R square plus of z square. That's it. R square into 1 into r square plus z square is equal to 3z square. So you are going to have something like this. You already know the solution. Not do work around it. I think this should be it. And then that means 2z square is equal to r square. That means z should be r by root 2. Plus or minus would be there, which means it indicates on both sides. Okay, of course, you take a root, there would be a plus or minus sign. Okay, very simple. Don't worry about it. It's one of the easiest. So that's it. Now we'll do a thing. We'll do like 2 or 3 problems, and then we'll deal with rest of the problems tomorrow. But this is the part. Okay, one is this like your spherical problems is one of the most important things, and then this ring based on the axis of the ring. Then I would say in the basics, I don't think there are chances. Maybe around your field there are high chances. I don't think even superposition it would be. If it's superposition, it's probably going to be potential or field. Okay. And the next could be this. This could be one of the most probable things that could be asked in your exam. Okay, this is just guessing from the pattern of your electrostats. Okay, how do you deal with such question given to you? Okay, I'm giving you an we'll solve 2 or 3 problems today, but you need to understand how to do this. There should be an immense clarity in your mind. Given to you a gravitational field. Now what do you need to do? You need to find out the gravitational potential at 2, 2 in joule per kg. Okay, forget it's all in SI units. So basically we need to find out the value. How do we work around this? It's a very simple problem. First of all, understand this point, what I'm going to define. dr is nothing but some dx I cap plus dy j cap position vector, right? It's a differential position vector, same thing, right? So think about it. R is equal to x plus xi plus yj plus zk. This is nothing but the same thing but differentiated. Easy? Pretty easy? Yep. It's an easy one. It's definitely. Think about it. R is equal to xi cap plus yj cap plus zk cap. What did I do? I took dr on the both sides. With respect to what? Nothing. I'm just taking a differential distance. Same thing has been done. You need to understand this thing. Why? We'll come to the point. Very simple. So I'm going to say something like this. Focus on knowing. You know this thing, right? What is Eg? Eg is nothing but minus dVg by dr. That's it. Know this. What is minus dv actually? It should have been actually, if you are not thinking this way, it should have been something like vector eg field dot of d. Okay, this should have been also been associated with a vectorial symbol. Okay, so you are going to deal with something like this. I'm going to substitute whenever I, j, k is given to you instead of r cap, you need to do this. If it's r cap, you can directly integrate it with dr. Okay, dr could be written as dr r cap. Else it would be written as dx I cap plus dy j cap plus dz k cap. That's it. It's really that simple. Now let's get into the calculation. It's really simple. Okay, do remember this thing, do note it down, and of course this thing. This is also. I'm not giving you any shortcuts yet. I'll come to the shortcut part soon. But that is not a shortcut. That is also like like a kind of a fact. We'll do that. Okay. Okay. Now here comes the thing. In this case, I need to calculate what? Gravitational potential, right? And I have a field value. Okay, what is the field value? That is something written over here. We'll later on interchange that. But before that, I'm going to write. So we are not going to deal with dz yet. I may not have to necessarily write down that thing, but let's do this. Okay. I hope everyone understood. We don't have to write down dz actually. Dz, z cap is not at all, k cap is not at all required. Let us k back k. Okay. So this is what we are going to do. So minus dvg is equal to minus 20 into I cap plus j cap. Okay, into that of dx I cap plus dy j cap plus dz k cap, and dot of only like vector remains, and dot of perpendicular vector disappears. So I dot j would disappear, I dot k would disappear, only I dot I would be there. Similarly, j dot j would not be would be there, and rest would disappear. Minus would get cancelled. What I was saying is there's going to be only 20 dx plus of I dot I, rest would not be any significant, and j dot j. So 20 dx plus dy. Okay, and what do we need to do? We need to integrate it. Okay, generally it would be said that the potential at 0, 0 is 0. That's when you get it, but questions can be this. So we have to integrate it to find the potential at some point x comma y comma z, but z is not involved in this thing. We're not going to talk about z. This is going to be integration of 20 dx. Separately it will be integrated, right? Plus of 20 dy. From where to where? We don't know. Some 0 to x, 0 to y. Assuming generally potential at 0 can be given as a constant value, some value, then you need to definitely substitute. Okay, this is going to be from 0 to x, and this is going to be from 0 to y. There you go. It's going to be 20x plus of 20y. That is going to be 20 into x, y. So this would, if you integrate this is going to be 20x minus 0. So 20x, and this is going to be 20y minus 0, 20y. That's it. And I think we don't have any space. Let's do a thing. This is value at any x comma y. And what we need to do now? We need to do something known as substitute the value of x. Substitute the value of x, y. That is the next thing. Let me do a thing. I'm going to take a blank page. So do remember it was 20x plus y. I can take out x and y as common. So in such cases, you will get a function like this. You need to derive it. You need to integrate it. You need to take the dr and basically take a dot with the field, and you will be getting some expression in x and y. This is rather the simplest starter beginner. Okay, and we are supposed to find out at which point? At some point 2 comma 2 in this case. What was x comma y? This is x comma y, right? So x was x comma y is equal to 2 comma 2. So you know this thing. Then you need to substitute it and get the answer. So Vg is going to be how much? Vg is going to be 20 into 2 plus of 2. That's it. That's 4 into 20. It's 80 some SI units. I think it's 80 joule per kg, etc. Okay, that's it. Okay, it's work done per unit mass. That's how I remember it. That's all it is. Simple as that. All right. Now let's get into the next problem. Let's do a thing. I'm going to give you a quick way of doing this problem, given that you have dealt with the earlier problem. So think about it. In such cases, what I can do is, if at all given that the potential at origin is taken to be 0, so again a value of field is given to you, the minus of 5 I cap plus 12 j cap Newton per kg. Now you need to find out the ratio of potential at point 12 to that of 5. So the ratio of potential at 12 to that of potential at 0, 5. 12, 0 and 0, 5. Okay. I'll give you a a very easy way of doing it, and rather than integrating etc. So if you notice that this kind of thing, only this kind of thing, the straightforward value in terms of I cap and j cap is given to you. Okay, this is kind of that term that is not dependent upon x and y, where your gravitational field is not dependent upon x and y. What you need to do is you can do this thing. Okay, you can integrate and find out this thing, but you can think about it like this. Given that, let me write it down. Given potential Vg is equal to 0 at 0, 0. Now the thing is, how do you derive the potential? This is what you need to do. Okay. It's basically minus Vg is equal to E dot of R, vector R, or R cap. Even R cap, that's just vector R. I'm really sorry, it's vector R. Have been R cap. What I said up until now is correct. I don't think there is any issue. Now the thing is, you can write it down as something like this. In the specific case, what is that specific case? This is a specific case. What is that specific case? In the specific case, it should not be a value, like a field should not be a value dependent upon x and y. What do I mean by that? We'll see that tomorrow. So it's really that simple. So let's do this thing. So you have like minus of 5 I cap plus 12 j cap dotted with x I comma y j dotted, you'll be getting 5x plus 12y. So minus of 5x plus of 12y. That's it. Okay, this is a standard thing if your field is tending to be that way. This it's simple. So this is minus Vg, right? So your Vg value is going to be 5x plus 12y. We are going to deal with 5x plus 12. So for any x comma y, we will be writing down the field value to be something like this is going to be 5x plus 12. Now the thing is, what is the potential at 12, 0? Let's call this as V1, and that is nothing but V of 12, 0 you should be substituting the value of x 12 by 0, of course. That's like 60. V1 is 60, and similarly we'll be calculating V2. V2 is at point what? 0, 5. So it's going to be 0, 5. Going to be I'm dealing with which expression? I'm dealing with this expression. Okay. So that's going to be how much? 5 into 0 plus of 12 into some 5. Okay, you'll be getting again a 60. Okay, good. So that means what is the value of V1 is to V2? What is the ratio of the potential? 1 is to 1. That's it. V1 is to V2 is going to be 1 is to 1. Ratio is going to be. Oh, everyone of you know this. Alright, easy, simple. But we have many more problems coming up. Many more interesting problem coming up. Like, you know, some coordinates are given to you. How do you find out gravitational potential? Some field equation is given to you in terms of x. How do you find out gravitational potential? Like, I'll take it from the basics until advanced as I do it in every chapter. So don't worry about it. Stay tuned. And of course, many more things. We have many more model problems coming up very soon. And what if that's actually very easy. Finding out from field to gravitational potential is the task. Do remember, I've discussed everything in terms of your equation. You must be recalling those things. We'll be soon getting into such problems, partial differentiation if you remember. So we'll be doing a few more problems for your understanding, but everything should be thorough by the end of this next session, next session. There are many more problems coming up. This could be one of the probable places where you'll be soon getting your problems. And that being said, students, this Sunday from 10 a.m. to 12:30 p.m. we are going to have a problems and vector session, and this is going to be the part 7 thing. Why am I saying this is part 7 thing? We have already completed 2 parts. Okay, sorry, 7 parts, 6 parts. I'm really sorry, not 2 parts, 6 parts. In those 6 parts, we have discussed the theory of vectors completely. So these are like full and complete sessions for your JEE preparation, available for free of cost on your Unacademy learning app. And this time we are going to discuss these problems and vectors. And yes, I'm calling this part 7 because I typically recommend that you go through the 6 parts of your vectors so that you have a complete understanding of vectors. And especially 11th class students, if you do not have a good understanding of vectors, this time to attend it. And even 12th class students, you can complete it and within drop us 12th class students. Like 2 days is what you would require to complete this vectors. And if you have completed it or even not, try and attend the Sunday session so that way you will be able to understand what you need to do like during your exam problems. We'll be discussing a mix of basic mathematical and physics based vector problems. So it's going to be a definitely interesting session. Also, do not forget to ask your friends to attend this session. It's from 10 a.m. to 12:30 p.m. on this coming Sunday. So it's a free of cost special class. And that being said, students, on Monday we are going to have JEE Mains 2020 problem discussion on electrostatics, again from 10 a.m. to 12:30 p.m. And students, yes, it's again a free of cost special class. It's going to be really interesting, so make sure you're attending it, especially 2022 aspirants as well, because we'll be also learning some techniques to solve the problems. And make sure you are completing all the PYQ sessions 2021 aspirant. And we are going to have a PYQ session today at 7:30 as well on JEE English. But this is on Unacademy learning app. If you haven't attended it before, try and attend this session live. You can answer them on polls and you'll get leaderboards. It's going to be super interesting. So try and attend this session, this free of cost session, this coming Monday. And again, that being said, units, dimensions and measurements complete series is available for your JEE preparation on your Unacademy learning app. Again, all for free of cost. All you need to do is attend 4 plus there is one more model problem session. That's all you need to do, and your preparation around units, dimensions and measurements could be complete. We have discussed units based problem, dimension analysis of important quantities, error analysis, least count and measuring instruments, etc. In this just 4 sessions. That one additional session is for solving many more model problems, and of course we have discussed a lot of PYQs as well. So attended students, especially 2021 aspirants, this is the easy cakewalk chapter that you don't want to miss it, and it's also less time consuming. Even it's going to be easy in your exam. And 2022 aspirants, if you feel that you do not have completeness around your preparation, you can attend these sessions. Again, they are all available for free of cost on your Unacademy learning app. These are A to Z sessions. Yes, that being said, students, yes, if you're not yet on our Telegram Telegram channel, do first of all download Telegram app if you don't have one, and do get onto a Telegram channel. What you need to do, you need to click on that link that is available in the description box below, and you will be getting onto a Telegram channel. Yes, that's all you need to do. Yes, or else you can just type in JEE_English and you will be able to find us on Telegram. And students, what would you get? You would get before time updates on this A to Z sessions, YouTube sessions, and what we are going to do today, etc. And any flash news, etc. about your JEE preparation. Those all things will be available on this Telegram channel. Okay, and that being said, if you haven't downloaded the Unacademy learning app yet, just type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app, and click on this install button, and post that you'll be having an amazing app handy. And on this Unacademy learning app, or from this Unacademy learning app, once you follow me, you will be able to attend this free of cost A to Z sessions available on your Unacademy learning app, students. Yes, they are all available on Unacademy learning app for free of cost. This includes many more topics that we have completed. This includes vectors, units, dimensions and measurements, many more things. And these are like revision sessions, or it can be also starter session depending upon how you would like to proceed. Yes, that being said, not only that, you will also get access to many like free of cost quizzes. If you download an Unacademy learning app, you will get access to Unacademy Combat. So many more things once you have this Unacademy learning app handy. And that being said, the most competitive gamified IIT JEE battle ever is going to happen again on 3rd of Jan. So this 3rd of Jan we'll be having, that is after your new year, we'll be having this most competitive gamified IIT JEE battle, and you can compete live and win lots of rewards and prizes. This includes hundreds of Amazon vouchers, and MacBook Air, MacBook Air and Apple iPad, AirPods, many more things, many more interesting prizes. So compete live, and you can take it also as a learning experience, because you're going to compete with really a very interesting and a competitive crowd. And we have dedicated competitions for 11th class, 12th class and droppers. So do enroll, and anyone trying to attend it, do attend it, planning to attend it, do attend it, and enroll today. And make sure you apply Murli Live code. As I told you, you can unlock many features using Murli Live code, and you can get special discounts even on your Unacademy purchases, be it subscription or anything that you do. And make sure you're getting a complete package for your JEE preparation with Unacademy subscription, because we have the best educators across the nation on an Unacademy subscription platform, where you would be getting to attend daily live interactive classes with them. Not only that, students, that too on a very interesting platform with lots of polls and leaderboards. So your learning becomes very interesting and fun. And the Unacademy subscription has a lot of test series. So a lot of national level test series are going on Unacademy subscription. This way you will be able to assess your position, improve upon your mistakes, and make many more improvisations to your learning. And of course you will be getting also an amazing analysis with your test series. And students, that being said, you will also get access to live doubt clearing sessions on Unacademy subscription platform. In fact, every program on Unacademy subscription platform is structured program, and you will get access to live doubt clearing sessions on every program, and you'll be getting this dedicated live doubt clearing sessions, so that you are able to maintain completeness with each topic. And also each Unacademy subscription program comes with lots and lots of quizzes and mega quizzes. So it's going to be a structured learning with the best educators across the nation on the best platform. And yes, this could be one of the best things for your JEE preparation. And guys, how do you avail Unacademy subscription? All you need to do is click on the left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal, and then hit on this get subscription button. Yes, that's all we need to do, and you'll have an amazing app handy for your JEE preparation. And all you need is one subscription and unlimited access throughout the period. Yes, with one subscription, there is no restriction on any batches that you can attend, and we provide like programs for both JEE Mains and JEE Advanced on Unacademy subscription platform. And coming to the pricing part, also it's very reasonable. All it is going to cost you is 2100 per month, that is less than 70 rupees a day if you go for a 24-month subscription. And we typically recommend students in 9 to 11 class that you take like a 24-month subscription like at this pricing, and it's an amazing pricing. Of course, you get to this price point after you apply Murali Live code, so make sure you apply Murali Live code, be it on any kind of Unacademy subscription purchases, so that you can get the best discount. So don't miss out the discounts on your subscription purchases. Make sure you are applying Murali Live code, be it you're unlocking new features. And that being said, students are we have pay in parts payment option, and also something known as no cost EMI. And these two payment options typically take away the hassle of paying all the fee at once, and you don't have to worry about it. You can split your payments comfortably into multiple parts, and you can avail an Academy subscription. And of course, we do also have other payment options like debit card and credit card. These are two interesting payment options that I like to discuss with students, because they typically reduce the hassle of paying all the fee at once if you're looking for one such option. And of course, students, we do also have a 12-month program for JEE aspirants. We typically recommend this for droppers, long-term students, and students in 12th class, etc. And what do we have for you? We have dedicated droppers batch, micro courses, crash courses, many more things going on Unacademy subscription platform. And students, only at a price of 2,888. So think about it, all you have to pay is less than 2,900 to get a full-fledged platform, a complete package for your JEE preparation. And students, yes, do apply Murali Live code so that you can get the best discount on your subscription purchases. So make sure you're applying Murali Live code for best discounts. And that being said, this was all about plus subscription. We have something known as iconic subscription, which is little beyond your plus subscription. What do I mean by little beyond? Yes, on iconic subscription, we not only provide all the things that you get on like plus subscription, whatever we have discussed until now. Apart from that, you'll be also getting personal coaching from IITians and NITians. So think about it, you'll be getting strategy sessions, expert guidelines, and IIT JEE workshops from IITians and NITians who have previously gone through this journey and who have cracked the exam successfully. So they will be guiding you throughout this journey. Not only that, they'll be coming up with the do's and don'ts depending upon your preparedness, etc. For your JEE preparation. So if you can afford it, it is one of the best things for your JEE preparation. And how do you avail it? You need to choose iconic subscription, and then you can choose one of the two programs depending upon which year you are in. The 12-month program is going to cost you only 58,500, and if you go for a 24-month program, all it is going to cost you is less than how much? 50,000, 45,000 per year. And make sure you apply Murali Live code, be it on iconic subscription, plus subscription, 6-month subscription, 12-month subscription, or 24-month subscription to avail the best discounts on your subscription purchases. And that being said, our team is right now on iconic subscription. Now you can take your JEE preparation to the next level with our personal coaching, IIT JEE workshops, expert guidelines, test analysis, study planner, etc. And students, yes, one of the best things could be like you're learning from our team, because we have IITians, NITians, head of coaching institutes on our team. And yes, students, we also have many more authors on Unacademy subscription platform, and also some of the best educators. So you can learn from them, and you can get expert guidelines and JEE workshop from us as well. And if you prefer to do it in English, you can do that. And that being said, the Manzil batch is going to begin tomorrow, and there is also going to be a rank booster batch 2.2 that is going to be conducted by the the same team of educators, some of the best educators for your JEE preparation. So think about this team teaching you on Unacademy subscription platform. And do not forget to like and share this video. Definitely do share this video on your social media, because someone in need will get access to amazing lectures for your JEE preparation. And yes, do like this video. Do not forget to like this video, and you can click on that subscribe button. Do click on that subscribe button so that you get timely notification, and also on that bell button do make sure you're doing both of these things so that you're getting in time updates, etc. And that being said, students, yeah, do share and share the video, and keep smiling, work hard, but also work smart. And that is what we are going to discuss in today's PYQ session. PYQ sessions are like, not a typical session with just concepts, but also techniques to solve your PYQs. Make sure you're attending this, one of the most important PYQ session, that is on your current electricity. Do not miss it out. See you at 7:30 today, students. Take care, stay safe, bye bye, and stay tuned. Like gravitational lectures, don't miss them out. Take care, stay safe, bye bye.